Hello students and good afternoon. So now I'm doing class for class 12. The topic is the same topic that we were doing in the last online class, that is standard integrals. So today also we will do the same chapter, that is standard integrals. Same exercise 6b, 2 mark section, page number 363 from the book Higher Mathematics for class 12 by SN Day. So let's do this question number 12 now. So question number 24 is you have to evaluate this integration of dx divided by x square minus 2ax. Okay, so let us first write I is equal to integration of, this is dx divided by x square minus 2ax. Now you have to convert this integration into standard form. Now you know standard form number 1, 2, 3, 4, 5 and 6. Okay, so you have to convert this integration into that standard form. But in this case, both these x are the variables. X square is the variable, here also x is the variable. So you cannot directly change it into standard form. So if you have both the terms like x square and x, you have to convert it into the form of a square minus 2ab plus b square, or it may be a square plus 2ab plus b square. Now since there is minus sign in between these two terms, you have to convert it into a square minus 2ab plus b whole square. Okay, so यो दुईटै भेरिएबल छ, x स्क्वायर पनि x पनि भेरिएबल छ भने यसलाई तिमीले डाइरेक्टली स्ट्यान्डर्ड फर्ममा चेन्ज गर्न सक्दैनौ। त यसलाई हामी के गर्नुपर्छ, x स्क्वायर र x टर्म छ भने चाहिँ यसलाई हामी पर्फेक्ट स्क्वायर लान्छौँ। पर्फेक्ट स्क्वायर भनेको चाहिँ a स्क्वायर माइनस 2ab प्लस b स्क्वायर कि त a स्क्वायर प्लस 2ab प्लस b स्क्वायर। बट बिफोर दैट always make the coefficient of x square positive 1 always. Okay, so already here the coefficient of x square is 1, so you don't have to make it 1 here because it is already the coefficient of x square is positive 1. Okay, so there are two terms here, x square minus 2x. So let us convert it into the form of a square minus 2ab plus b whole square. Okay, so or I is equal to integration of, this is dx, now divided by what is a whole square, this is x whole square, minus 2 into what is a, x into what should be the value for b here. This x square is correct, this is only minus 2x. What should be the value for b here, so that we can get 2ax. 2x is already there, so the value for b should be a plus, what is b whole square? This is a whole square. Is that clear? Now these first two terms are correct here. This is x whole square is x square, minus 2xa is minus 2ax, but again there is one of the terms, that is a square here. But is there a square here? In the question, is there a square? No. But here we are getting a square, but you have to cancel it. So you can write minus a whole square. So I think you have understood it. So or this is I is equal to integration of, this is dx divided by, what is the formula here? A whole square minus 2ab plus b whole square. So what is the formula in this case? It is x minus a whole square minus a whole square. So I think you have understood it. Okay, so now this is the standard form. So instead of x there is x minus a, and instead of a there is a. So this is the form integration of dx divided by x square minus a square. So this is the formula, integration of dx divided by x square minus a square, which is equal to, what is the formula? It is 1 upon 2a log within mod x minus a upon x plus a plus c. So here x is x minus a, and what is a here? It is a. Instead of x there is x minus a, and what is a here? It is a. So let us use this formula in this case. Okay, so or I is equal to, first of all it is 1 by 2a, 1 by 2 into what is a out here? It is a log within mod. What is x minus a? Here x is x minus a. Then minus, what is a here? This is a divided by x plus a. What is x plus a? Here x is x minus a plus, and then you should write a. So mod sign closed plus c. So or I is equal to 1 upon 2a log within mod. What do we write? X minus a is minus 2a divided by, here a gets cancelled, you'll get only x, mod sign closed plus c, and here the base is e. Here you can write the base is e. You can write base as e. Is that clear to all of you? So this is the final answer here. So this is the formula, right? Here this base is e. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 25. So question number 25 here is, you have to evaluate this integration. That is integration of dx divided by 2ax minus x square. Okay. So let us write here first, I is equal to integration of dx divided by 2ax minus x square. Okay. So here also both these two terms contain the variables. 2ax is the variable, x square is also the variable. So you cannot directly change it into standard integrals form, because both the terms contain the variable. That is, one of them is twice ax and the other one is x square. So I already told you that whenever there is x square and the term containing x, you have to convert it into a perfect square form. It may be a square minus 2ab plus b whole square, or it may be a square plus 2ab plus b whole square. Okay, and always you have to make the coefficient of x square positive 1. So here the coefficient of x square is minus 1. So make it positive 1 first by taking minus common. तो यसमा पनि 2ax पनि छ, x square पनि छ. The x square पनि छ, x पनि छ भने तिमीले यसलाई के फर्ममा लानुपर्छ? पर्फेक्ट स्क्वायर फर्ममा लानुपर्छ. That is a square minus 2ab plus b square form, or a square plus 2ab plus b square form. And always you have to make the coefficient of x square positive 1 by taking minus common. Okay, so here the coefficient of x square is minus 1. So let us take minus 1 as common to make the coefficient of x square as positive 1. So therefore I is equal to integration of dx divided by, let us make the coefficient of x square positive 1 by taking minus common. So within bracket what do we have? X square minus 2ax. Okay, now within bracket there is x square minus 2ax. Let us convert it into perfect square form. That is a square minus 2ab plus b whole square. So or I is equal to integration of, this is dx divided by minus within second bracket, what is a whole square? X square minus 2 into, what is a? X into. So here we are getting x square, but there is 2ax, but there is 2x. What should be the value for b so that we can have 2ax? It will be a plus, what is b whole square? That is, here the value for b is a, so plus a whole square. So we are getting these first two terms, that is x square minus 2ax. But again we are getting here a square. But is there a square here? No, you have to cancel it. So you have to write minus a whole square. Here second bracket is closed. So I think you have understood it. So or I is equal to integration of dx divided by minus within second bracket This is a square minus 2ab plus b whole square. What is the formula? Now this is x minus a whole square minus a whole square, second bracket is closed. Okay. Now since we have taken here minus common, again multiply this expression by minus sign and write down the positive term first. Okay. So, or this is I is equal to integration of dx divided by, let us multiply it by minus sign, and so it is minus into minus is plus. Let us write plus a square first, then minus this is x minus a whole square, this is your x minus a whole square. Is that clear now? So this is the value for I. So here instead of a there is a only, and instead of x there is x minus a. Here the variable is x minus a, you can take it as x, and here the constant is a, that is the value for a. So in this case we can use this formula, integration of dx divided by a square minus x squared. This is standard form number 3, that is the third standard form. So what is the formula? It is 1 by 2a log within mod a plus x upon a minus x mod sign closed base e plus c. Okay. So in this case, if we compare these two, what is the value for a here? It is a. What is the value for x here? It is x minus a. So or I is equal to, what is the formula? 1 upon 2 into a log within mod. What is a plus x? Here a is a plus what is x? X minus a divided by, in the denominator, what is a minus x? A is a only, minus what is x? X minus a. But because of this minus sign, it will be minus x minus into minus plus a, mod sign closed, plus c. So I think you have understood it. So let us simplify it further. Here a gets cancels. So or it is I is equal to 1 upon 2a log, here you can write down the base as e. So log within mod, what do we get? It is x divided by m. This is a plus a is 2a, and this is minus x, mod sign closed, plus c. Here the base is e. So this is the final answer. So I think you have understood it also. So you can copy it. Now we'll do the next problem. So now we'll do the next section, that is from the 4-mark section, and this is integrate. Question number 1, you have to evaluate this integration, that is integral of dx divided by within square root x square minus ax. Within square root there is expression x square minus ax. Now in this case you should know some methods in this case. Okay, now I am telling you the methods, listen it carefully. So if the expression is under square root, and if the expression is in the denominator, and if the expression is under square root, and if the coefficient of x square is positive, if it can be factorized, then factorize it. If the expression is within square root, if the expression is in the denominator, and if the coefficient of x square is positive, and if the expression can be factorized, then you have to factorize the given expression. कुनै एउटा एक्सप्रेसन छ अन्डर स्क्वायर रुट डिनोमिनेटरमा छ र कोएफिसिएन्ट अफ एक्स स्क्वायर पोजिटिभ छ र यो एक्सप्रेसन फ्याक्टराइज हुँदैछ भने फ्याक्टराइज गर्नु. त फ्याक्टराइज गरेपछि यु विल गेट टु फ्याक्टर्स, then we can take any one of the factors as z square to convert into standard form. Is that clear? मैले भनेको बुझ्यो सबैले? If the expression is under square root, if the coefficient of x square is positive, and if the expression can be factorized, you can factorize it. Is that clear? कुनै पनि एउटा एक्सप्रेसन छ अन्डर स्क्वायर रुट र कोएफिसिएन्ट अफ x स्क्वायर चाहिँ पोजिटिभ छ र त्यो एक्सप्रेसन फ्याक्टराइज हुँदैछ भने फ्याक्टराइज गर्नु फ्याक्टराइज गरेपछि यु विल गेट टु फ्याक्टर्स देन वी क्यान टेक वान अफ द फ्याक्टर्स एज z स्क्वायर तर यदि एक्सप्रेसन यो फ्याक्टराइज हुँदैछ तर कोएफिसिएन्ट अफ x स्क्वायर चाहिँ नेगेटिभ छ भने चाहिँ डोन्ट फ्याक्टराइज इट फ्याक्टराइज हुँदैछ भने पनि नगर्नु बुझ्यो किनभने त्यो डाइरेक्टली हामीले के फर्मुला लाउन सक्छौं 6th स्ट्यान्डर्ड फर्मुला लाउन सक्छौं जसको फर्मुला चाहिँ हो इंटीग्रेशन अफ dx डिवाइडेड बाइ रुट अन्डर a स्क्वायर माइनस x स्क्वायर इज इक्वल टु sin इन्भर्स x by a plus c that is the simplified expression. Is that clear now? So now in this case the expression is under square root, it is in the denominator. The coefficient of x square is positive here and you can factorize this expression. So let us factorize it, okay? So let us write here first I is equal to integration of dx divided by root over this is x square minus ax, okay? Here the expression is under square root which is in the denominator. The coefficient of x square is positive here and it can be factorized. So let us factorize it. So I is equal to integration of dx divided by root over what is common here, x is common and within bracket we have x minus e. So it is factorized. So both the factors are within square root. Take one of the factors as z square. Let us assume one of the factors as z square. कुनै एउटा फ्याक्टरलाई हामी z square suppose गर्छौं. Either it may be x is equal to z square or it may be x minus a as z square. जुन चाहिँलाई तिमीले z square suppose गर्दा पनि हुन्छ. Either you can assume x minus a as z square or x as z square. तर एउटालाई मात्रै हामी z square suppose गर्छौं. ठीक छ? So let x लाई suppose गरे x is equal to z square. So this is the method of substitution. Let us differentiate it. So differentiating both the sides. So differentiating both the sides with respect to z. Okay. So therefore this is dx by dz is equal to 2z. Now cross multiply it. So it is 2x dx is equal to you cross multiply it, you will get dx is equal to 2z dz. So let us put these values in I. So therefore I is equal to integration of what is dx now? It is 2z dz. It is 2z dz divided by within square root. What is x now? It is z square. And within bracket what do we have? What is x? Z square minus a. It is z square minus a. Is that understood now? So now what will you do in the next step? 2 is constant here. Take it outside integral sign. So or I is equal to 2 integration of this is z dz divided by what is square root of z square? Z and then within square root we have z square minus a. Is that clear? So here this z will be cancelled. So or I is equal to this is 2 integral sign dz divided by root over this is z square minus a. So this is the simplified form of the expression. अब यसलाई हामी के फर्मुला लान्छौं? स्ट्यान्डर्ड फर्मुला लान्छौं. So which standard form is used out here? You can use this formula integration of dx divided by root over x square minus a square, isn't it? So what is the formula in this case? It is log within mod x plus root over x square minus a square mod sign closed. The base is e then plus c. Okay? So let us convert it into standard form. So instead of x there is z square and this is a. So a should be put within whole square. So or I is equal to 2 integral sign this is dz divided by within square root it is z square minus a within whole square is root over a whole square. So we can compare these two integration. Let us compare this integration with the standard form. So instead of x there is z, instead of a there is root over a. That is, a is kept within whole square. So it is root over a whole square. So let us use this formula in this case. Okay. So or I is equal to 2 into log within mod. What is x? It is z, plus root over what is x square? This is z square, minus what is root over a whole square? A mod sign closed plus c, and here the base is e. So I think you have understood it. Okay, so we have used the formula. This standard integral is used out here. So now let us put the value for z and z square. Okay, so or I is equal to 2 log within mod. What is the value for z? Since here x is equal to z square, what is the value for z? Root x. It is root over x plus root over what is z square again? Here z square is x. So this is your x minus a mod sign closed plus c. So this is the final answer. And here what is the base? The base is e. So this question is very, very important. So you can mark it. So I think you have understood the method for doing this question number 1. Okay. So you can copy it. Now we'll do the next question. So now we'll do this question number 17, and 17 and 20 are similar type of problem. So 20 is your homework. Okay, so question number 20 you can do it at home. So let's do this question number 17. So you have to evaluate this integral of dx divided by within square root. It is x square minus x minus 6. So let us write here I is equal to integration of dx divided by, it is root over x square minus x minus 6. So I already told you the method now. Just now I already told you about the method while doing the previous problem. So within square root there are terms containing x square minus x minus 6. Okay, and here the coefficient of x square is positive. And I already told you that if you can factorize the expression, if the coefficient of x square is positive, then factorize the expression. Can you factorize this given expression x square minus x minus 6? Yes, we can do the middle term breaking here. So let us write here, this is x square minus x minus 6. So let us do the middle term breaking while factorizing it. So if you multiply those two numbers, you should get 6. Multiply the two numbers, you should get 6. And after subtracting that two numbers, you should get the coefficient of x, that is 1. Okay. Here the coefficient of x is 1. Here x square coefficient is 1. 1 into 6 is 6. And before 6 there is minus sign. So if you multiply those two numbers, you should get 6. And after subtracting those two numbers, you should get the coefficient of x, that is 1. Okay, so it is 3 2s are 6 and 3 minus 2 is 1. भयो त यहाँ लेख्न सक्छौं हामी x square minus 3 minus 2 into x minus 6. You know how to factorize it by middle term breaking. Okay, so it is equal to x square minus 3x minus minus plus 2x minus 6. So what is common out here? X, this is x minus 3 plus 2 common within bracket x minus 3, which is equal to x minus 3 into this is x plus 2. So we have got the two factors. One is x minus 3 and what is the other one? X plus 2. So let us write down this factorization out here. Let us write down the factors out here. Okay. So or I is equal to integral sign dx divided by, it is within square root, we have this is x minus 3 into x plus 2. Is that understood now? So both the factors are within square root. So let us assume one of the factors as z square. Okay, either you can assume x minus 3 as z square or x plus 2 as z square. जुन चाहिँलाई सपोज गर्दा पनि हुन्छ. ठीक छ? So let us assume z square is equal to the first factor, that is x minus 3. You may assume z square is equal to x plus 2 also. You will get the same answer. Okay? So let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So therefore, what is the differentiation of z square with respect to x? It is 2z into dz by dx, which is equal to 1, right? Differentiation of x with respect to x is 1. Differentiation of 3 with respect to x is 0, that is constant. So you can do cross multiplication. So 2z dz is equal to, how much is it? It is dx. Is that understood now? So we have got the value for dx, which is in the numerator, as 2z dz. So let us write it here. I is equal to integration of what is dx? 2z dz. So it is 2z dz divided by, within square root, what is x minus 3? It is z square. Let us write here z square, and within bracket we have so now here x minus 3 is z square. So we have put the value for x minus 3, which is equal to z square. Now we have got here x plus 2. So now you should put the value for x. So from here you can get the value for x. X is equal to, this is z square plus 3. That is, we are putting x is equal to z square plus 3. So from this method of substitution, that is z square is equal to x minus 3, we can get the value for x, which is equal to z square plus 3. So let us put the value out here. So what is x here? It is z square plus 3. Z square plus 3, and there is plus 2. Bracket closed. Or I is equal to 2 is constant taken outside. Integral sign z dz divided by, what is square root of z square? That is z, and it is root over z square plus 3 plus 2 is 5. So I think I've understood it. Okay, so here this z gets cancels. So or I is equal to 2 integration of dz divided by root over, this is z square plus, let us convert it into standard integral. Okay, now this is your standard integral. Which standard integral is used out here? We can use this standard integral, that is integration of dx divided by root over x square plus a square, which is equal to, what is the formula? This is the fourth standard integral. It is log within mod x plus root over x square plus a square, mod sign close, the base is e, then plus c. Okay, so here x is z. What is a? Root 5. So let us use the formula. Or I is equal to 2 into log within mod, what is x here? It is z plus root over, this is x square is z square plus root over 5 whole square, mod sign closed, plus c. Okay, now put the value for z. Or I is equal to 2 into log within mod, what is the value for z? Since z square here is x minus 3, what is the value for z? Root over x minus 3. it is root over x minus 3 plus root over, what is z square? Here z square is x minus 3 again. Let us put z square is x minus 3, right? Here z square is x minus 3. So we have put it out here, x minus 3 plus what is root over 5 whole square, that is 5. Then mod sign closed plus c. Okay. So next, or I is equal to, here the base is e, you can write here the base as e. Okay. So it is 2 log within mod, the base is e. It is root over x minus 3 plus root over, this is x plus 2 mod sign closed plus c. So this is the final answer. So I think you have understood it. So this question is also very, very important. So similarly, you can do this number 20. So number 20 is your homework. Okay. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 21. You have to evaluate this integral of dx divided by within square root. There are two factors, x minus alpha into x minus beta. That is, these are already factorized. So we can use the same method as we have done in the previous one. Let us take one of the factors as z square. Either you can take x minus alpha as z square or x minus beta as z square. Okay. So that is the method now. So therefore let us write here first, I is equal to integration of dx divided by root over, this is x minus alpha into x minus beta. So let us take one of the factors as z square. जुन चाहिँ फ्याक्टरलाई तिमीले z square suppose गर्दा पनि हुन्छ. So let us take this x minus beta as z square, right? So let z square is equal to x minus beta. You may take z square is equal to x minus alpha. Okay. So this is the method of substitution. Now you have to differentiate both the sides with respect to x. So differentiating both the sides, with respect to x. So it is 2z into dz by dx is equal to 1. Differentiation of x with respect to x is 1. And here beta is constant. So differentiation of beta with respect to x is 0. Right? So we can do cross multiplication here, or 2z dz is equal to what? It is dx. Okay. So from here, let us get the value for x, because in the first factor, instead of x, you have to put the value for x in this case. You have to put the value for x in terms of z square. Okay. So what is the value for x from here? So it is x is equal to z square plus beta. Right. So therefore, I is equal to integration of, what is dx? It is 2z dz. It is 2z dz divided by within square root. Now within bracket in the first factor, what is the value for x? Z square plus beta. It is z square plus beta, then minus alpha, bracket closed. And what's about this x minus beta? It is z square. This is z square. Is that clear now? So let us simplify it further now. Let us simplify this expression. So therefore, I is equal to, here 2 is constant taken outside. Integration of, here it is z dz. Here it is z dz divided by, in the denominator, what is square root of this z square only? That is z. You can take it outside. Z, then root over, it is z square plus beta minus alpha. So here this z will be cancelled. Okay. So or I is equal to, let us convert it into standard form now. So it is 2 integration of dz divided by within square root, here x square is z square, plus, now this beta minus alpha can be written within whole square. So how can you write this beta minus alpha as within whole square? It is root over beta minus alpha whole square. Now which standard form is this one again? It is integration of dx divided by root over, this is x square plus a square, which is equal to, what is the formula in this case? You know that it is log within mod x plus root over x square plus a square mod sign close base e plus c. Okay, so you can compare these two integral. Instead of x there is z, instead of a here it is root over beta minus alpha. So we can use this formula now. So or I is equal to 2 into, what is the formula? Log within mod, what is x? Z plus root over, what is x square? Z square plus, what is a whole square? It is root over beta minus alpha whole square, mod sign closed, the base is e, so it is plus c. Okay, or I is equal to, this is 2 log, here the base is e within mod, what is the value for z? What is the value for z square here? X minus beta. What is the value for z? It is root over x minus beta, right? So it is root over x minus beta plus root over, now we can put the value of z square here. What is the value of z square? X minus beta. This is x minus beta plus, what is root over beta minus alpha whole square? So it will be beta minus alpha mod sign closed plus c. Okay, so here this beta gets cancels, or I is equal to, this is 2 log within mod base is e within mod, we have root over x minus beta plus, it is root over x minus alpha mod sign closed base e then plus c. So this is the final answer. So I think you have understood it, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 2. So you have to evaluate this integration, that is integral of dx divided by within square root 2x minus x square. So how will you evaluate this integration? Okay, therefore I is equal to integration of dx divided by root over, this is 2x minus x square. So how can you evaluate this integration? Here also the expression is within square root. Expression can be factorized, but the coefficient of x square here is negative. So I already told you that if the coefficient of x square is positive only, then you can factorize it. But if the coefficient of x square is negative, don't factorize it. Just you have to convert it into standard form. So you will get the standard form number 6, which is very easier to use the formula. Okay, and that is the simplified form, that is 6th standard form is sine inverse x upon a. So directly this integration can be converted into this integration can be directly converted into 6th standard form, and that 6th standard form is sine inverse x upon a. Is that clear? So if the coefficient of x square is negative, don't factorize it. If the coefficient of x square is negative, don't factorize it, you just convert it into a standard form. Okay, so or I is equal to integration of dx divided by within square root. Now you have to convert into a standard form. So both x square and x square, both x square and x is there. Both the terms containing x, both the terms contain x square and x. So you have to convert into perfect square form, a square minus 2ab plus b square form. Before that, make the coefficient of x square positive 1. So here minus is taken common within bracket, x square minus 2x. Here minus is taken common. So first of all, you write down the term containing x square, and it is minus into plus minus, then it is 2x. But you cannot factorize here because the coefficient of x square is negative. So now we have to convert this x square minus 2x in terms of perfect square. That is a square minus 2ab plus b square, or it may be a square plus 2ab plus b whole square. Okay. So or I is equal to integration of dx divided by within square root minus within second bracket. So let us convert it into perfect square form. That is, what is a whole square? X square minus 2 into here x is a is x, and what sort of the value for b, so that we can have only 2x. Already 2x is here. By which number will you multiply this 2x to get 2x? That is 1, isn't it? So 2x into 1 is 2x. Plus here the value for b is 1. So it is 1 whole square. So this is a perfect square, right? So we are getting x square, we are getting minus 2x, but there is 1 whole square. This is extra number, but here it is not 1 whole square. So you have to cancel it. So you have to write minus 1 whole square. So this second bracket is closed. So I hope you have understood it. Okay. So or I is equal to integration of dx divided by within square root minus within second bracket. So what is a whole square minus twice ab plus b whole square? It is x minus 1 whole square. Then minus 1 whole square is here. Let us write down the last one, that is 1 whole square. Okay. Or I is equal to integration of dx upon, it is dx divided by, now within square root, let us multiply by minus in this case, so that we can write down the positive term first. That is minus into minus plus 1 whole square. Minus into minus plus 1 whole square. Then write down minus x minus 1 whole square. Minus this is x minus 1 whole square. Okay. So now in this case the value for a is 1, which is the variable x minus 1, that is taken as x. So which formula is used in this case? That is integration of dx divided by root over, this is a square minus x square, which is the sixth standard form, that is sine inverse, this is x upon a plus c. So we can use the formula in this case. Or I is equal to compare these two integral. Here the value for a is 1, here the value for x is x minus 1. So let us use the formula. What is the formula? It is sine inverse, what is x? X minus 1 divided by what is a? It is 1, bracket close, plus c. Or what do we get? So I is equal to, this is sine inverse x minus 1 plus c. So this is the final answer. So you should remember that whenever the expression is under square root, and if the coefficient of x square is negative, don't factorize it. But if the coefficient of x square is positive and the expression is under square root, if you can factorize the expression, factorize it. Okay. But if the coefficient of x square is negative, don't factorize it. Just convert it into sixth standard form, so that we can use the formula of, that is integration of dx divided by root under a square minus x square, which is equal to sine inverse x upon a plus c. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 3. You have to evaluate this integral. That is, you have to find out the value of this integration. That is integral of sec square x dx divided by within square root 5 minus sec square x. So how will you do this integration? So let us write here I is equal to integration of, this is sec square x dx divided by within square root 5 minus sec square x. So how can you evaluate this integral? Now in the numerator there is sec square x. Now you should know differentiation of which function is sec square x? That is your tan x, isn't it? Differentiation of tan x is sec square x. So let us convert this sec square x, which is in the denominator, in terms of tan square x. So what is the formula for sec square x in terms of tan x? You know this formula. Sec square x is equal to 1 plus tan square x. You should know this formula, right? So this is from the class 10. Okay, you have done it in class 10, this formula. So or I is equal to integration of, this is sec square x dx divided by within square root, it is 5 minus, what is the formula for sec square x? It is 1 plus tan square x. Okay, so let us simplify it further. Or I is equal to integration of, this is sec square x dx divided by within square root, what is here? It is 5. This is minus 1 minus plus. Let us open this bracket. Minus plus minus, that is your tan square x. Is that clear? So or this is I is equal to integration of, this is sec square x dx divided by root over, this is 5 minus 1 is 4 minus, this is tan square x. So I think you have understood it. So now let's do the method of substitution. Differentiation of which function is which one? Differentiation of tan x is sec square x. So let us assume z is equal to tan x. So let z is equal to tan x. So now let us differentiate it. This is the method of substitution. We can differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So therefore dz by dx is equal to, how much is it? It is sec square x. Okay, now cross multiply, or dz is equal to, this is sec square x dx. So we have got the value for dz, which is equal to sec square x dx. So in the numerator, instead of sec square x dx, we can put dz. So therefore it is I is equal to integration of, what is sec square x dx? It is dz divided by within root, this 4 can be written as 2 whole square minus, what is tan square x? Tan x is z, so it is z square. So this is your z square. So I think you have understood it. So which formula is used here? Here a is 2 and x is z. So we can use the 6th standard form here again. That is integration of dx divided by a square minus x square is equal to, what is the formula that you can use here? It is sine inverse x upon a plus c. So we can use the formula in this case. Or I is equal to, let us compare these two integral. This is the standard form. Here a is equal to 2 and here x is z. So what is the formula? It is sine inverse z upon 2 plus c. Is that clear? Now let us put the value for z. Or I is equal to, this is sine inverse within bracket, what is the value for z? Z is tan x, right? So it is tan x divided by 2 bracket closed plus c. So this is the final answer. So I think you have understood it. So you can copy it. The आज हामीले जति पनि प्रब्लम्सहरु गर्यौं, you revise all the problems at home. Okay, so try to remember that 6 standard forms. Okay, so you can easily do the problem. So in the next online class we will do more problems on these standard integrals. So this much is for today.